Good morning, everyone. Welcome to today's financial maths lesson. My name is Khadile Mampolo, the tutor and the maths senior education specialist at Johannesburg East District, South Africa. As I said, today's lesson is about grade 12 financial mathematics, as said in the syllabus of South African curriculum. Now, at the end of this lesson, you must be acquainted with the annuities, sinking funds, loan repayments, including the fixed withdrawals when certain amount of money is invested. Now, let's look at the annuities. When you talk about the annuities, you talk about series of equal payments made at equal intervals. In grade 11, you learned about the investments where one only invests the lump sum for a certain period. But in annuities is when you save fixed amounts at equal intervals. For instance, if you go to the bank and make a stock order to say you want them to deduct 2,000 rand every month or every quarter or every semi-annual for a certain period. So that amount must be the same, must be fixed, and then time interval must remain the same. Now, we use what you call an annuity future value formula. X is that fixed payment. I is the interest rate as a decimal, meaning if it's in percentage, then you divide by 100 to change it to decimal. Then you also consider the compounding period. N is the number of payments. In grade 11, we defined N as time, but in this case, it's defined as a number of payments. You'll see when we work out some of the questions why we see N is the number of payments. Then we have F as a future value, then the formula as shown on the right-hand column. Now, let's look at worked example 1. Semi decides to save 1,500 at the end of every month over the next 4 years, starting immediately. If the interest earned is 11% per annum compounded monthly, how much will Semi have in the account at the end of 4 years? Now, let's highlight the keywords. It's very important every time when you read financial math statement question to highlight or to underline the compounding period. This happened for 4 years, and it was compounded monthly. The reason why you have to consider the compounding period, it will definitely define your N. It will definitely determine your N. Let's collect our data here. So obviously you see that that fixed payment is 1,500. Then you change R to I, was 11%, you say 11 over 100, then it's 0.11, then you divide it by 12, which is our compounding period. And then N will be 4 times 12, so which is we are converting the time to months. Remember, 4 times 12 is 48. But now, if you look at the words, there's a phrase starting immediately. It means in the first month, the 1,500 was paid twice, or what was deposited twice at the beginning of the month and at the end. Then from there, Semi continued to do that every month. Hence, we add 1 because at the in the first month, Semi made 2 payments. Now, then the total of 49 payments will be made. It means 49 payments will be made over a period of 48 months. So then you substitute, then you punch on the calculator to get the answer. So meaning that at the end of the 4th year, Semi will have 92,258 rand 62 cents. Now let's look into next word example. I didn't change other values, but I just wanted to consider this when the first payment was made. Now, in this question, we say starting in 1 month time. So it means everything will be the same except that n will just be 48 times 12 equals to 48. So it means now here it says 48 because it started in 1 month time. So it means you made 48 payments out of 48 months. Then you substitute and get the answer. So in this case, then you substitute and it means Semi will have, if Semi start in 1 month time, Semi will have 89,934 and 23 cents. Excuse me. I also in example 3, I didn't change anything except that Semi will start in 2 months time. If Semi starts in 2 months time, then it simply means that Semi in 48 months, he only made 47 payment. He missed the first month. So that is hence we have 47. Then you substitute, and then it means Semi will have 87,680 rands 94 cents within a 48-month period. But N is 47 because it started in 2 months' time. Then it means it missed the first month. Now again, I changed here. Now, in this example 4, Semi decides to save 2,000 Rand at the end of every 3 months over the next 5 years, starting immediately. If the interest earned is 8% per annum compounded quarterly, how much will Semi have at the end of 5 years? Compounding period is highlighted again. So it's quarterly. So it means time must first be converted to quarters. Since the interest is compounded quarterly, okay, first of all, obviously it will be X, which is 2,000, is our fixed payments. We converted R to I, then it will be 0.08, and then we say N is 4 times 5. Why do you say 4 times 5? Because it's compounded quarterly. So we convert years to quarters. Then since it started immediately, we add +1. This means that in the first quarter, which is 3 months, Semi paid at the beginning of the quarter and at the end of the quarter. Hence, we have 21 instead of 20. So then you substitute and get the answer. So it means Semi will have 51,566 rand 66 cents. He still decides to save 3,000 at the end of every 3 months over the next 4 years, starting in 3 months' time. If the interest earned is 9% per annum compounded quarterly, how much will Christy have in the account at the end of 7 years? As you always do, highlight the keywords. So it's compounding period and when semi started. Now, in this case, X obviously will be our fixed payment. Then you can convert percentage to I. Say 9 divided by 100 is 0.09 divided by 4 because it's compounded quarterly. Then you convert your time. You say N will be 7 times 4, which is 28. But in this case, since Christie started in 3 months' time, it didn't miss any quarter. And then it means in the first quarter, which is 3 months, she paid once, then he paid every quarter. That is why it will stay 28. Now you substitute, and then it means at the end of 7 years, if Semi deposit 3,000 at the end of every 3 months for 7 years, then it means Semi will have 29,645 rand 97 cents. Example 6. Grace decides to save 1,850 at the end of every 3 months over the next 10 years, starting in 6 months' time. If the interest earned is 11.4% per annum compounded quarterly, how much will Grace have in the account at the end of 10 years? As we did, highlight or underline the key words. So we'll start in 6 months' time, and then the interest is compounded quarterly. Let's collect data. X will be 1,850. Then I, you convert percentage to I, then you say 11.4 divided by 100, then you divide by 4 because it's compounded quarterly. In this case, if Semi starts in 6 months' time, remember this is compounded quarterly, and quarter of a year is 3 months. So if you start in 6 months, so it means Grace missed the same quarter. Grace missed the first quarter, which is 3 months. So if Grace missed the first quarter, then it will be 28 minus 1. So in this case, Semi started in 6 months' time. It simply means that the first payment was made in the second quarter. So hence we subtract 1 because the first quarter was missed. Then the answer will be 38. So first we say 10, which is the 10 years times 4, which is from the compounding period. Then we say minus 1. Then the answer will be 39. So then you substitute. If this is the case, it means Grace will have 129,307 rand 93 cents at the end of 10-year period. If 1,850 is deposited every 3 months, starting in 6 months' time, with the interest at 11.4% per annum compounded quarterly. Presley decides to save 850 at the end of every 6 months over the next 4 years. So over the next 8 years, starting immediately. If the interest earned is at 8.5% per annum compounded semi-annually, how much will Presley have in the savings account at the end of 8 years? As we always do, highlight or underline the keywords, starting immediately and also compounded annually. So this is done every 6 months. But since this is compounded semi-annually, remember semi-annually is 6 months, which is the half of the year. So we'll have to first convert our time to semi-annuals. That is where there you say 8 times 2, which is 16. We say plus 1. So why do we say plus 1? Because it started immediately. So meaning that in the first half of the year, Presley made 2 payments and continued to make 1 payment at the end of every semi-annual. Then the N will be 17 in this case. then x will be 850, then convert 8,5 to I, you say 8,5 divided by 100, then you divide by 2 because it's compounded semi-annually. It means at the end of the 8 years, uh, you'll have 20,581.39 rand. So the same formula is still the same, the annuity future value formula, because we talk about fixed payments. Thabang opens savings account by depositing 7,500 on the 1st of July 2025. He plans to deposit another amount of 7,500 6 months later and continue to deposit the same amount at the end of every 6 months. How much will Thabang savings worth on the 30th of November 2030 if the interest earned is 12% per annum compounded semi-annually? As we always do, we check compounding period. Since Thabang started on the 1st of July and then did that every 6 months, it means in 2025, you make 2 payments, then it's 2 in 2026, 2 payments is 4, 2027, 2 payments is 6, 2028, 2 payments is 8, 2029, 2 payments is 10, and then 2030 is 1 payment because it's doing every 6 months, but it stopped on the 30th of November. So meaning that you stop before you make the 12th payment. That is why N will be 11 in this case. So your X is 7,500. Your I will be 0,12 divided by 12. Remember, I converted percentage to I first to say 12 divided by 100. Then we say over 2 because it's compounded semi-annually. The N is 11. Then you substitute on the future value formula, then you get the answer. It means at the end of the period, Thabang will have 112,287 rand 32 cents. Now, Rand decides to save 6,000 at the end of every year over the next 12 years, starting a year later. If the interest earned is at 10.5% per annum compounded annually, how much will Grant have in the savings account at the end of 12 years? Compounding period semi-annually, it means this is the effective rate. So N will just be 12 because it started in a year later. So it means no time period, no payment was missed. So our X will be our fixed payment, then I will be 0,105. We don't divide by anything because it's compounded annually, because it's the effective rate. Then we substitute, then you get the answer. This means that in the 12 years period, Grant will accumulate 132,226 rand 32 cents. Now, next example, Rambo wants to accumulate 500,000 in 6 years. He decides to open savings account by saving X rands at the end of every month, starting immediately. The interest earned is at 12% per annum compounded monthly. Calculate X. Now, in this case, Rambo want to have 500,000 in 6 years is what he's targeting, but you still want to make a fixed payment. This means that you are still falls under the annuity because the fixed payment will be made. So as we always do, highlight the keyword, 12% per annum compounded monthly. Highlight the keywords or the key phrase. Now, I would be 0.12 because you converted 12% to I and then over 12. Then you say N 6 times 12. Why do you say 6 times 12? Because this happened over a period of 6 years. This will happen over a period of 6 years. So, and then it's compounded monthly. Then you say 6 times 12, which is equals to 72. But because it started immediately, it means in the first month, Rambo made 2 payments and then continued to make 1 payment every month. Hence, we have 73. So substitute your 500,000 because it's what is targeting, then it's our future value. Then we substitute, then we get X, then we cross multiply to get X. So the denominator on the right, multiply to the numerator, and you divide. You take the numerator on the right hand side to the denominator, then you get X. So it means that if Rambo saves 4,683 rand 53 cents over the period of 6 years with that interest of 12% per annum compounded monthly starting immediately, then he will be in a position to reach his 500,000 rand target within that period. Work example 11. Mafuta wants to accumulate 1,200,000. He decides to open savings account by saving 6,500 at the end of every 3 months, making first deposit 3 months later. The interest paid is at 14% per annum compounded quarterly. How many deposits should he make to reach his target? As usual, highlight the key phrase. This is compounded quarterly. And then this will, it will be done within a certain period. And then, but we don't know the number of payments that payments of 6,500 that Mafuta should make to reach the 1.2 million rand target. Let's collect your data. Our F is 1,200 rand. Sorry, it's 1.2 million, which is what Mafuta is targeting. And then a fixed payment, 6,500. Then our interest is 14% compounded quarterly. Then it's a 14 divided by 100, which is 0.14 divided by 4 because it's quarterly. Then you substitute on the future value formula. Then everything substituted here. You cross multiply to get this, and then obviously, if this -1 comes this side, then you'll have 97 over 13. Then normally, please avoid rounding off in every step. The answer will be incorrect. So I'll advise you, if your answer on your calculator can be a fraction, leave it as a fraction and substitute on the log as a fraction. So those who are using Casio, if you go to the key just below the on key, you'll find the log, then you substitute. Then in the small brackets, you put the base of n, and then in the other bracket, you put the number on the other side. If you did it correctly, then it will be, means your n is 58,4208. And then it means 59 quaternary payments should be made. Because now, when I say 59 payments, it is because in financial measures, don't necessarily round off. Because if we can round it off and say n is 58, then Mafuta's investment will not reach his target. It will be closer, but it will not be 1,200,000. So for him to be safe, for him to reach the target, it means 59 payments must be reached. But if we make equal payments of 6,500, it will be over. It will be a bit over 1,200,000, but it will not be less. Because remember, if you want to reach the target, he must make 59 payments. If make 58, then the money would be less than 1,200,000. Lesera opened savings account with the deposit of 100,000. 5 months later, she added 1,700. Thereafter, she kept on adding 1,700 at the end of every month. This means how much will be in Lesera savings account at the end of 10th year if the interest earned is 12% per annum compounded monthly? The interest is compounded monthly. And then our future value in this case would be, now, the reason why we added this using the formula that we used in grade 11, it is because this 100,000 rand was once-off payment. So it's not an annuity. It was once-off payment. But since it stays in the account for the whole period, so it means it will gain interest for 120 months, which is 10 years. So that is why we didn't substitute on the annuity future value formula, because it was once-off payment, but it gained the interest for the whole period, which is the 10 years. But since this is compounded monthly, then it means your N will be 120. It means it will earn the interest for 120 months. The interest there, 12%, we convert it to decimals, we divide it by 100 and over 12 because it's compounded monthly. Then on the annuity future bill formula, you'll substitute 1,700 because it was a fixed payment. Then N will be 116 because the deposit of 1,700, the monthly one, was done 5 months later. Then it means that they were missed 4 months in between. Then that is why N here it will be 120 minus 4, which is 116, because it was done 5 months later. Then it means at the end of 10-year period, Lesera will have 726,557 rand 95 cents. Conman decided to open the savings account with fixed monthly payments of 5,000. He kept on adding 5,000 at the end of every month for a period of 6 years, starting 1 month in 1 month time. Due to financial difficulties, Conman missed the 13th, 14th, and 15th deposits, and then thereafter he resumed with the deposit of 5,000 until the end of the period agreed upon. How much will be in Conman's savings account at the end of 6 years if the interest earned is at 9.8% per annum compounded monthly? Highlight the keywords: 9.8% per annum compounded monthly. Now, in this case, in the annuities, if one missed payments in the middle, remember in annuities, they won't penalize you because it's your money. So once you miss the payments, the system will stop where you stopped and then calculate the amount separate from when you resume. So since Conman only made 12 payments before he missed. So then here N will be 12. But now the money accumulated in 12 payments was not taken. Conman didn't take the money. It means the money accumulated out of 12 payments will accumulate the interest for the remaining period. Remember, 6 years is 72 months. It means this is 12 here, and it means the remaining period from the 13th to 72, it will be 60. Remember, 6 years is 72 months. So it means the amount accumulated in 12 months will accumulate the interest for the remaining period, which is 60 months. Then when he resumes, then you will take the remaining period. How do you calculate the remaining period? Then it will be 72 minus 15. Last time he missed, then 72 minus 15 is 57. Then when you calculate, it means at the end of 6 years, one man will have 463,359 rand 63 cents in the account. Stanford decided to open savings account by depositing 8,000 at the end of every 3 months for 5 years, starting immediately. Due to financial difficulties, Stanford stopped making payments 9 months before the end of the period they agreed upon. How much will be in Stanford's account at the end of 5 years period if the interest earned was at 7% per annum compounded quarterly? Now, as we do always, highlight the keywords. First, Stanford stopped 9 months before the period they agreed upon. Stopped making payments 9 months earlier, and the interest is compounded quarterly. What does this mean? It means Stanford stopped 3 quarters earlier. So meaning that Stanford missed the last 3 quarters, which is 9 months. So it means first you have to check compounding period. It's compounded quarterly, and then this is done in 5 years. So you say 5 times 4, which is 20. But because Stanford only made, remember it was supposed to be 5 times 4, which is 20, plus 1, because he started immediately, and then it was supposed to be 21. But because he missed 3 quarters, then it will be 21 minus 3, which is 18. But there's no statement which says Stanford took the money then. Then it means the money will accumulate the interest for the remaining 3 quarters. Hence, you have 3 there. So it means at the end of 5 years, and the Stanford will have 176,508.67 in the account. Now, let's look at the sinking fund. A sinking fund, this is the amount added to buy the new asset after the same but old asset has been traded in. For instance, if you buy an asset and tell the dealers that after a certain period, I'll come and trade in the asset, add the money to buy the new asset. So the money you add to buy the new asset after you have traded the old one in is called the sinking fund. So in other words, the sinking fund is the price of the new asset minus the price of the old asset, meaning that obviously when you bought the asset now, so as your asset loses value, the one in the shop will increase in value according to inflation. Inflation being the increase of prices. Now, so That is what I'm saying, the sinking fund. It will be the price of the new asset at the time you trade in the old one, minus the price of your asset after it has gone through the depreciation. The book value of the asset. So the book value and the scrap value, they mean almost the same thing. The book value and the scrap value, they mean this almost one and the same thing. And then, but both of them, the similarity is that they have something to do with depreciation. The book value is the value of the asset during its useful time. The scrap value of the asset is value of the asset at the end of its useful time. In other words, if you buy an asset which has a lifespan of 5 years, if you sell it before 5 years, then you are selling it with a book value. Then if we sell it after 5 years, we are selling at a scrap value. Does not mean that if we say scrap value, then it's a scrap. So the book value is the value of the asset during its useful time. The scrap value is the value of the asset at the end of its useful time. So meaning that if you sell it within its lifespan, you are selling it with a book value. If you're selling it after its lifespan, you are selling it with at a scrap value. Sinking fund works example 1. Mike bought a car for 389,500. He decided to sell it back to the dealer with its book value after 3 years and buy the same car brand. So in other words, add the money. The depreciation rate of the car is at 13% per annum on a reducing balance method. The value of the car increases according to the inflation rate, which is at 16.8% per annum compounded, 66.8% per annum. Now, calculate the book value of the car. Now, let's say this. When you calculate the book value, like I said, book value has something to do with depreciation. It means the rate that you're going to use will be the depreciation rate, which is, excuse me, which is 13% per annum on a reducing balance method. So, excuse me. And then P will be 389,500. N will be 3 years. And then I will be 0.13. And A is unknown, which is the book value of the car. Now, then since we are using the reducing balance method, we know that the reducing balance method you learned it from grade 11, which is A is equals to P into 1 minus I to the power N. Sometimes they call it a diminishing balance. Then you substitute and get the answer. It means when Mike sells his car, it will worth 256,486 rand 92 cent at the time he sells it. Then that's the book value of the car. It means he sells the car before within its lifespan. Calculate the price of the car at the end of 3 years. So obviously, when you talk about the price of the new car at the end of the 3 years, so inflation will be considered. And inflation is always the compound interest. There's no inflation of a simple interest. So P is still the same, N is still 3 years. I will be the appreciation rate, or the increasing rate. So the inflation is always a compound interest. Then you substitute to the compound interest formula. Then it means at the time Mike sells his car, it lost value, but the new one, the shop according to inflation, it will be 474 rand, 474,483 rand 62 cents. This will be the price of the new car when Mike sold the new, or when Mike sells the old car that he was using. Number 3, calculate the sinking fund. As I stated, sinking fund will be the price of the new car minus the difference between the price of the new car and the price of the old car. It means this is 17,996 rand 70 cents. It means this is the money that Mike have to add to buy the new car after he have traded the old one in. Mike now, and before that, if someone make the fixed payments, invest the money as fixed payments in order to target the sinking fund that he'll need to buy the new asset, we say the person is setting up the sinking fund. So Mike is setting up the sinking fund by opening a savings account. He saves X every month, starting 4 months after the car was bought. The interest earned on the savings is at 11.5% per annum compounded monthly. Calculate X. So meaning that F is the sinking fund that Mike is targeting, which is 217,996.70 cents. Then N will be 33. Why is it 33? It is because Mike will sell the car after 3 years. And then this is compounded monthly. Then it will be 12 times 3, which is 36. But since Mike will start in 4 months' time, so it means that he missed first 3 months, then this money will be accumulated in 33 payments, not necessarily years. I think this must be removed. So it means Mike will accumulate the sinking fund in 33 payments, and then of payments of 5,647 rand 70. So it means if we deposit this money, this 33 payments of this money and then at the end of the 3 years, then it means you'll have 217,996 rand 70 cents, and then add to buy the new car. Kenny bought a laptop for 22,000 and agreed with the dealers that he will sell it back to them when its scrap value is 13,320 rand 65 cents, and add the money to buy the new one. The laptop depreciates at 11.8% per annum on a reducing balance method. The inflation rate is at 5.5% per annum. For how many years will Kenny use the laptop? That means you want the N here. Let's check. Now, since we are given the scrap value, then obviously we'll use the reducing balance method formula. Then because we were given the scrap value. But if we were given the price of the new car, then we'll use the compound interest formula and the inflation. So it means we used the reducing balance formula because there's enough information for it. So the scrap value then is given. Then the price of the original price of the car is given. Then which is 22,000. Then the depreciation rate is 11.8. Then you divide by 100 to be 0.118. Then N is unknown. Then you say you divide there, then you have that, then you use the log key. And remember, I told you that at the bottom, you use the key that below the on key on the Casio. Then the bracket here, you always put the base of X, of N now, and then here you put the other one, you put the number on the other side. then N will be 3,9999, and then N will be 4 years. It means Kenny will sell the car after 4 years. Calculate the price of the new laptop when Semi sells the old one. So obviously, you consider inflation, then which is the increasing rate. Then now, and we know it is 4. Then we substitute there, and then you get the price of the new laptop. Sorry, the price, not the car. The price of the new laptop. So remember, use compound interest because inflation rate will always be a compound interest. Calculate the sinking fund. As you said, is the price of the new asset minus the price of the old asset. Then it means if Kenny want to buy the same new laptop, and then you'll have to add the 18,940 rand 49 cent on top of the. Remember, I will sell the old one, we'll trade the old one in, and then add the money to buy the new laptop. Then he set up the sinking fund by opening the savings account. He saves X rand every 3 months, starting 6 months after the laptop was bought. The interest earned on the savings is at 9.75% per annum compounded quarterly. Compounding period, very important. F is the sinking fund calculated in the previous slide, and it will be 15. It is 15 because it will be 4 times 5. Remember, it's quarterly. You say 4 times 5. You change your years to quarters. But since he started 6 months after that, then it means Kenny missed the first 3 months, which is the first quarter. Then that's why it will be it will be it will be first to say 4 times 4, which is 16. Remember, it's 4 years times, because 4 times 4, because it's 4 years and it's compounded quarterly. Then you say -1 because you missed the first quarter. Then N will be 15. Then I will be the rate, the interest rate earned on the savings. Then you substitute here, then you cross multiply to get the value of X. It means if Kenny invest 780 rand 95 cents for 4 years with the interest compound of 9.75% compounded quarterly, starting in 6 months' time, then he'll be in a position to reach the target of his sinking fund. Now, let's look at loan repayments. Now, in loan repayments, so this future value formula, I think the heading here, it will be the future value formula. Now, the future value formula is used in loan repayments and also to determine a fixed withdrawals at equal intervals, and also is used. We use this present formula. So, in other words, when this present value formula can be used in loan repayments, and also when you talk about withdrawals, just like, for instance, if you invest a certain amount of money, then you withdraw fixed payment at equal intervals, then we still use the present value formula, because the money that you invested is not what you will have, is what you have at that moment. Then it's like you invest it there, then you take a certain amount every month. But remember that money, because you say you invest it, then it will gain interest. And then when you are determined to calculate the time you can take to survive with the money that you are withdrawing from that invested amount, then you use the present value formula. Then you see in the next slides. So he takes out a loan of 50,000. He makes first payment 1 month after the loan was granted. He agrees to pay the loan in 7 years. The interest charged on the loan is at 12% per annum compounded monthly. Calculate Solis monthly installment. Now, P is the loan, which is 50,000. I is, then you will say 12 divided by 100, which is 0.12 over 12 because this compounded monthly, and would be 7 times 12. 7 times 12, which is 84. Now, X, then we substitute, then we cross multiply as you have seen that, then it means Soli will pay the loan by means of the payments of 882 rand 64 cents for 84 months, or he will make 84 equal payments without missing. Next one, Sam took out a loan of 250,000. He makes first payment 2 months after the loan was granted. He agrees to pay the loan in 6 years, and then the interest charged on the loan is at 9% per annum compounded monthly. Calculate Sam's monthly installment. Now, in this case, P will be the loan, which is 250,000. Then your I will be 9 divided by 100, which is 0.09 over 12. And then N would be 6 times 12, 6 times 12, which is 72. But now, because it started 2 months after that, then it will be 71. Then we're supposed to say -1 there because they started 2 months later. Remember this, you were supposed to make monthly payments for 72 months, but now it started 2 months after that. But unlike with annuities, when you miss payments, it does not mean that the loan will stay the same at the time you make your first payment. It means they will charge you the interest for the month that you missed. Meaning that if they say, come and take something, and you don't worry, you pay after 3 months, it's not a question of a favor. They know that when you make your first payment, you'll be owing. You'll be owing more than what you have taken. They will charge you the interest of the months that you missed. So meaning this bracket here, it means it's the loan taken plus the interest of the 1 month that you missed. That's why N is 1 here. Remember, when exponent is 1, you don't write it. So it means they charge you the interest of 1 month, then you'll pay the rest in the next 71 months. Then you substitute cross multiply, that X will be 4,588 rand 48 cents. Kyle took out a loan of 300,000. He made first payment 5 months after the loan was granted. He agreed to pay the loan in 10 years. The interest charged on the loan was at 11% per annum compounded monthly. Calculate Kyle's monthly installment. Before I forget this, I just want to indicate that normally in loan repayments, they will say compounded monthly, because now we relate this to real life situations. It's right for a loan to say you pay every quarter, but I'm not ruling out anything. But in most cases, it will be compounded monthly. Let's collect the data. P will be 300,000, and then I will be 0.11 over 12. Then N will be 10 times 12 equals to 120. Then this will be equals, then X will be unknown. Now, here is 5 this is done in 10 years, then 10 times 12 is 120. Then, but your P in this case will not be necessarily be 300,000. It means when Kyle makes his first payment, you'll be owing. Remember, first payment will be made 5 months after the loan was granted. It means Kyle will will be owing 300,000 plus the interest of the first 4 months because he made first payment 5 months after the loan was granted. Now, then it means now out of 120 months, it will be -4. Then this side it will be minus 116. Then you do the same thing, cross multiply, then the answer will be 4,367 rand 75 cents. Mariah took out a home loan of 1,300,000. He made first payment. She made first payment 8 months after the loan was granted, and then she agreed to pay the loan by means of 120 equal monthly payments. Then interest charge on the loan is at 13% per annum compounded monthly. Calculate Mariah's monthly installment. So obviously, because Mariah made the first payment 8 months after the loan was granted, it means he missed 7 payments. So that is why a P will be the loan plus the interest of the 7 months that he missed. So, but unlike in the previous one, we said we subtracted the time charged here. But now in this one, the statement does not say he agreed to pay the loan in 120 months. It says he agreed to pay the loan by means of 120 equal payments, even if there were penalties for missing 7 months. So it's still 120 here because agreement was not on time, but on number of payments. So then we cross multiply again to get 20,931 rand 6 cents. Lucky takes out a loan to buy a car costing 620,000. He makes first payment 4 months after the loan was granted. He agrees to pay the loan by means of 84 equal payments. The interest charged on the loan is at 10.5 per annum compounded monthly, just like the one that we have just done. He agreed to pay the loan by means of 84 equal monthly payments, meaning that it is not 84 months. So let's see. How much will Lucky be owing when he makes his first payment? Now, it means because Lucky started in 4 months' time, it means three months. So it means Lucky would be owing 620,000 plus the interest of the 3 months that he missed. Then it means when he makes first payment 4 months later, he'll be owing 636,417 rand 82 cents. Now, calculate Lucky's monthly installment. So obviously, monthly installment, then now the P is calculated in the previous slide. And then the N will still be 84 despite the penalty. So because he didn't agree to pay in 84 months, he agreed to pay in 84 equal monthly payments. So we substitute, the interest is there, divided by 12 because it's compounded monthly, then you cross multiply, it means the monthly installment would be 10,730 rand 43 cents. Lucky takes out a loan to buy a car costing 620,000. Oh, we're still on the same question. Calculate the total interest Lucky paid under 39th month. Now, when you calculate the total interest in the middle of the period you agreed upon, it's very important to first remember, as I said, we don't have to confuse the interest and the total interest. Sorry, the interest and the interest rate. The total interest is the extra money paid on top of what you've taken. Now, we need to calculate the outstanding balance. So outstanding balance, we have two formulae of calculating outstanding balance. I always prefer this one because you use the principal, the present value formula is given in the formula sheet at the end of the year. So you just use the same formula, but instead of P, you've put B. So you can't say you forget it because you just use the present value formula, then you say B. And then your X would be the monthly installment that is calculated in number one. And then the N will be time remaining. So the N will be time remaining. And then how do you do that? Then you say 84, which is the total number of payments that to be made, minus the last payment. So it means 84 minus 39, then N will be 45. So it will be the total time minus last time he paid. So then the answer will be, here it will be the outstanding balance after 39 months. This means that if Lucky can pay this amount just after the 39th payment, then the loan will be settled. So this is the outstanding balance after 39th month. You use the same present value formula, but instead of P, you put B. And then your N, X will be the installment, the N will be the time remaining, which is the total time minus last time Lucky paid. Then it will be 84 minus 39, then it will be 45. Then that's this outstanding. But as I said, if Lucky paid this amount just after the 39th payment, then it means the loan will be settled. So, but you use the present value formula. Instead of P, you put B for balance. Now, the total interest in this case will be the installment multiplied by the number of installment paid, which is 39, minus the loan. But now, because it's not the total interest at the end of the period, so then we'll have to subtract this outstanding balance from the loan. So you put in brackets to show that this outstanding balance is subtracted from the loan. So that is why the brackets are very important. So you say loan minus the outstanding balance. Otherwise, if we are just calculating the total interest at the end of the period, it will just be the 10,730,43 times 13 times 84, because we'll make 84 payments minus 620,000. But in this case, it's not at the end, it's at the in the middle. So that is why it is very important to calculate outstanding balance at that time. Then you say installments multiplied by the number of installment made at that time, which is 39, minus into, then you subtract the outstanding balance after 39 months from the loan, which is under 620,000. Then you get the answer, which is the 196,218 rand 5 cents. But don't forget that without the balance, you use the present value formula. Instead of P, you put B. Then N will be the total time minus last time you paid. Then it will be 84 minus 39 in this case. Calculate the total interest Lucky paid after. Then we did that. Suppose Lucky misses 40th 41st and 42nd payment due to financial difficulties. Here I deliberately said 40, 41, 42 because already we calculate the outstanding balance after 39 months so that we don't repeat the same step in this question. So now, if the first option is this, Lucky wants to pay new monthly installment for the remaining period without increasing time. What is the Lucky's new installment? Meaning that Lucky wants the new installments that he can pay when he resumes that will cover his arrears without necessarily increasing the time. He still want to finish the period they agreed upon. Remember, Lucky are supposed to pay this loan in 82 payments. So if he missed up to 42nd payment, it means after 42nd payment, the 42 it was supposed to be remaining making 42 last payments. So, but what is happening? Then it means like we're starting. We use the present value formula, but now we are going to look at the outstanding balance that we calculated in the previous question. So meaning because Lucky paid well for the first 39 months, so or Lucky made 39 payments without missing. It means he should not be penalized for the first 39 months. The only interest that will be added will be the outstanding on the outstanding balance after 39 months because he paid well for the first 39 months, which we calculated when we were calculating the interest. So this means that the interest of the 3 months that he missed, which is the 40th, 41st, and 42nd, will be charged on the outstanding balance calculated in the previous question. Then this is still the present value formula, the X, then N will be minus 42. Remember, Lucky does not want to increase time. So you want to finish within the period they agreed upon. So it means, remember, we left with 42, which is 84 minus 42. So then you cross multiply to get X. Then it means Lucky will pay this new installment for the remaining 42 months. He didn't want to increase the time, but he wanted to increase the installment. But first, if we didn't calculate, then the outstanding balance after 39 months. The first step will be to calculate the outstanding balance after 39 months. And then because Lucky paid well for the first 39 months, so 39 months must be excluded from the penalty. So we calculate the outstanding balance after that. Then they start charging the interest on the outstanding balance, which is 3 months in this case. But we still use the present value formula. Now let's look at the second option. If Lucky wants to pay the same installment and negotiate time extension, how many extra months will he need to settle the loan? Remember, we left with 42 months. But now, in this case, Lucky doesn't want to increase installment. He wants to pay the same installment of that we calculated in the first question. So, but he wants extra time to cover for the months that he missed. Remember, he left with 42 months. After he has missed 42nd payment, he was left with 42 months. We want to check how many extra months out of the 42 would be on top of the 42 left. Will he need to pay same installment to cover for his arrears? This step is still the same here. 3 months are charged. The interest are charged on the outstanding balance. The interest of 3 months are charged on the outstanding balance. Now, remember, this was the initial installment. Here, Lucky didn't want to change the installment. He just wanted to increase time. He wanted time extension. That's why now we calculate N. And then you will do this cross multiply this one, and then this one denominator. Then you take this one bracket, this side will be positive. What this one you calculate this side will come this side, it will be 1 minus the answer of this side, then it will be 0.66709075 meaning this bracket here, since it's negative, it go to the left. Then the answer you get here, it go to the right. Then you see 1 minus the answer you got on the left-hand side. Then it will be 0.66709075 Then you use the log as shown, but remember in this bracket you put the base of n, which is this, so write it as it is to avoid making rounding off. And then here you have to write the whole of it, and the answer will be minus n equals minus 46,4683 and so on. Then it then will be 47. This means it's 47. So it means since you are left with 42 months, this means he needs not 7, he needs 5 extra months, not 7. You need 5 extra months because you're left with 42. So meaning you left 5 extra months, it means that the time will be extended by 5 months then to settle the loan, but the final payment will be less because it was not exactly 47, it was 46,4683 and so on. Now, if Lucky considered the option in 4.2, calculate the final payment. Since we got the answer there, if you go back to this one, if you check, it was a decimal. Now, when you calculate the final payment, you still use the present value formula, but your n will be 0, comma the decimal you calculate when you get n. Why do you multiply by this? It means it will be outstanding balance after you made the 46th payment plus the interest of the 47th month. So, but your n will be 0, comma the decimal you calculated on you got when you calculate n. Then the answer will be the final payment. It means the last payment that Lucky will make will be 5,036.64 cents. You still use the present value formula, which is given in the formula sheet at the end of the year, but your this X will still be the installment, and then N will be the decimal. It will be the decimal, N will be the decimal digits on N that you calculated when you are calculating the number of installments, the extra time that would be needed for Lucky to cover his area. So this is installment, the interest is still the same, your N will be decimal, but you say 0, comma decimal, you got when you're calculating N times the interest of the last month. Let's say I bought a car costing 684,500. She paid 5,000 deposit and take the rest as a loan. She agreed to pay the loan by means of 84 equal monthly installments, making first payment 1 month after the loan was granted. The interest charged on the loan was at 12% per annum compounded monthly. Excuse me. Now, since now it's all paid 150,000, the loan will not be 684,500. Remember, the cash payment, the immediate payment should be subtracted from the loan. So it means the P in this case would be the price of the car minus the deposit. Then it will be, the loan would be 534,500. Then you substitute this one, and then you cross multiply, then the installment will be 9,435 rand 39 cent. So it means if you pay certain amount in cash, then it means it must be subtracted from from the price. Then the remaining one would be the loan, is the one that would be substituted as a present value, because they cannot charge you the interest on the amount that you paid in cash. That is why it must be subtracted. Calculate the total interest Lesotho paid after last installment. Like I said, the total installment is the total interest is the installment multiplied by the number of installments minus the loan. Then in this case, you are just going to say, what was installment? 9,435 rand 39 cents times 84, because you're supposed to meet 84 installments, then minus the loan. The loan was, we calculated the loan, which was 684,500 minus 150,000, then which is 534,500. Then this will be the total interest. But remember, I told you that when you calculate the total interest in the middle, then it means we need to consider the outstanding balance. So calculate the total interest Lesotho paid after 48th installment. So first we have to calculate the total the outstanding balance after 48th installment. As I said, outstanding balance, you use the present value formula, but N will be time remaining. Then remember, Lesotho was supposed to make 84 equal monthly installment. Then we are calculating outstanding balance after 48th installment. Then you say 84 minus 48, then your N will be 36. Then this will still be the installment. The interest is still the same. Then it means this is the amount that Lesotho will be owing just after he has made the 48th installment. So it means the total interest will be the installment times 48, which is the 48th installment, the time we refer to, then minus the loan. Like I said, you put in bracket, then you subtract outstanding balance from the loan. Then the answer you get will be the total interest. Thomas bought a car costing 393,850. He paid deposit of 15,000, took the rest as a loan. He agreed to pay the loan by means of monthly installments of 6,500, making the first deposit, making first payment 1 month after the loan was granted. The interest charged on the loan was at 10.7% per annum compounded monthly. As I said, deposit must be subtracted from the amount to get the loan. Calculate Thomas' law. You can just say 393,850 minus its 15%, or we can just say 100 minus 15 is 85. Then you say 393850 times 85 over 100, then you get the same answer. So remember, if it's 20%, then that other one will be 80 over 100. Just say 100 minus 15. So whether you say this minus is 15% or 85% of it, then answer will be the same. Calculate how many installments Thomas make to settle the loan. Excuse me. Then you'll just say, remember, we calculated the loan. The loan, we subtracted the 15%. Then the answer is this one. Then this is the installment. Then we are calculating N. Then it means this will be, as we did with the previous one, then cross multiply, get the answer. Then This one with negative will go to the left. Then this part will say will this part here will go to the other side. That's why you say 1 minus, then you get this answer. Remember, you don't round it off. You don't round it off. Then you say you put this, and then here you put the base of n. Then you put this other number on the other side. Then you get this one. This means Thomas will make 70 payments, but the final payment will be less than 6,500. Calculate the final payment. As I said, when you calculate final payment, you consider the decimal here. Then you say 0, that decimal would be your n. Then you still use the future value formula, and then this installment, but here it must be the interest of the last month. Then the n will be the 0, the decimal that you calculated there, then times the interest of the last month. Then it means the last payment will be 1,656.64 cents, meaning you'll pay the 69 payments as we've shown here. You'll pay the 69 payments of 6,500, and the last payment, which the 70th, will be 1,656.64 cents. Excuse me. Now, fixed withdrawals. So like I said, you can use the present value formula in fixed withdrawals. Let's say Paul invests 900,000 he wants from lottery. He intends to withdraw the 12,500 from the invested money at the end of every month. The investment earns the interest at 9.1% per annum compounded monthly. Now, let's look at this. Calculate the number of calculate the maximum number. I think we have to remove that, the number of the maximum. Calculate the maximum number of withdrawals Paul will make. So we are calculating the maximum number of Paul's withdrawals. We calculate the maximum number of Paul's withdrawals. How long will Paul survive with the 12,500 that you draw every month? So we calculate the number of withdrawals. As I said, we still use the present value formula, and then here it was mistake. This part should be removed. This the interest, it will just be the present value formula as it is. Then your present value will be 900,000. This will be 1,200. Then you calculate the n as we did. Cross multiply. You have this come this side. You see 1 minus that. Then you get that. Then your n will be 104, that. So it means Paul will be in a position to make 105 withdrawals, but you'll only make 104 withdrawals of 12,500, and then the final withdrawal will be less than 12,500. Let's calculate final withdrawal. It's just like a final payment. You will just use the present value formula, and then your n will be 0, the decimal. You calculate it on n. You got when you calculate n, then this will be the answer. It means the final withdrawal Paul will make will be 6,575 rand, 12 cents. Closing remarks. Life is a song, sing it. Life is a game played. Life is a challenge, meet it. Life is a dream, realize it. Life is a sacrifice, offer it. Life is love, enjoy it. These are the words by Sai Baba. Thank you very much for watching.